welcome back, even though we didn't really go anywhere. Our next presenter was with us last year and is back by popular demand. Reza Nassari is the CEO of the Landmark Group of Builders. He's committed to industry leadership and the introduction of innovation that will reduce waste, environmental impact, energy and resource usage in the homes built by the Landmark Group. And to that end, he's implementing his vision of home building as a highly efficient manufacturing process. Would you please join me in welcoming Reza Nassari? You're very welcome, sir. Thank you.
Morning, everybody. Just while I was sitting, it dawned on me that in North America, US and Canada, in a normal year, not last couple of years, of course, we build about 2.2 million homes. That is an enormous amount of construction. But housing is really not glorified because it's run by small companies, mostly disjointed. And that's why it hasn't really gotten anywhere. Building houses, again, still the same way as we built many, many years ago, like 50 or 60 years ago. We got lucky. We came across some new technology, and we adopted that. So we built single-family homes to multifamily. We have done high-rise or mid-rise, I should say. And we use BIM for the larger buildings, like the condominiums, or if it's larger than mid-rise. But many of the speakers talked about the large ones and much, much larger ones. So we're going to come down a little bit down to earth today and talk about small houses, just normal houses, and how we use BIM to manufacture them. So our vision is to be a North American housing solution providers. We're not thinking of being the biggest builders, but we want to be to be recognized for sustainability, and starting this, they call it, everybody said it's revolution, so we adopt that, but we want to change things. It's time to change the way we build homes, essentially. So at Landmark, we are in Edmonton, Calgary, and Red Deer, and most of our homes are in Edmonton, of course, the headquarters, and we build about 90% of our homes in Edmonton, not the multifamily, but the single family and up to townhomes, up to 3-story. In the plant today, a typical single family homes takes about 6 hours to assemble, and that's to lock-up stage, and that is, there's windows, insulation, roof, waterproofed, and lock up the door, and that's what we call in our industry a lock-up stage, and walk away. The rest is done in the factory. So result is shorter construction time, of course, material savings, which we will allude to as we go along, and much better quality. I heard about 1/16 of an inch. Our machines, of course, the efficiency, the accuracy is how sharp the saw is. So we could easily get 1/32 of an inch if we keep the blades always extremely sharp. So it's a very, very accurate process, and as we will see, it's a very efficient process. Productivity Alberta produced a video from our operations. We use a piece of it here to show for people who haven't seen that as an example. If you could run that.
For generations, the principles of how a home is built have remained the same. Landmark Building Solutions is changing all of that and is revolutionizing the industry from the ground up.
We will show them that this is the way of the future.
We can build any house that you want to your exacting specifications.
This is how you can make more money.
and put it up faster than you can possibly imagine with 100% accuracy every time.
And at the same time, revolutionize the industry.
The revolution began with Landmark's desire to build a better engineered home, a home that has the highest environmental standards, is affordable, and is ultimately a smart investment for the consumer. Taking a page from the auto industry, Landmark's revolutionary vision of the construction industry continues in the manufacturing plant. With unparalleled precision and efficiency, the computers in the plant instruct the machines to build many components of the home.
For example, if we cut a sheet and it's supposed to be exactly 300 millimeters, it's going to be exactly 300 millimeters, and it's going to fit exactly where it's supposed to fit on the wall.
Components are nailed together, and from there they go into the framing line, where they are placed into the wall in just the right sequence. The machine has the capability to make a 40-foot section of wall in minutes.
From there, the wall gets sheeted, and then it gets stood on its edge and moved into our spray foam area, where the wall is then checked for moisture content and then sprayed with polyurethane.
With these precise processes, the windows are inserted with ease. Then everything is checked to make sure it is tight and sealed, and then loaded onto the truck. In another area of the plant, stairs are being built and floor joists are assembled in 60-foot lengths, allowing for 3 or 4 jobs to be done at one time. A good example of precision in action is the floor panel assembly. They are cut to within a 1/16 of an inch, and the process resembles a finely tuned orchestra. All the components come together and are loaded onto a trailer, ready to be delivered to the site. Landmark's innovative approach to home construction becomes very apparent once the components arrive on site and the crew begins the assembly. They can have an average-sized home erected in 4 to 6 hours and ready for lockup. The speed and accuracy of this revolutionary method of construction has a number of benefits for the homeowner. Since the home components were built indoors and the home erected in less than a day, the wood has never been exposed to the weather. The precision in the plant continues to the site, with every element fitting easily into place. And with this method of construction, the homeowner will save money and have the comfort of knowing they have an energy-efficient home.
We talked about making money, not because I'm a greedy guy, but you know, the best way to entice other people to join this system, of course, is that to show them that there is money in it, and we all know that any time that you save time and you save the extra waste that we have in our processes, then that translates into money. So, and that's what's going to bring everybody, compel all the other builders actually to follow suit. So that is that's the wall line here that we see. These are just pictures, but it must be very clear to you now that when you see the machinery, that if there was no BIM or a 3D modeling, that they couldn't be manufacturing, because manufacturing, the machines need data, and without data, of course, they don't know what to do. So BIM is the most important part of the processes. So the wall is designed in the 3D. It has the details for every element in the wall, like the floor plan, like the plates, studs, backings, insulation, whatnot. Then for the skin, you see the OSB or the plywood, whichever is, again, designed. The dimensions, the nail patterns are established. So the accuracy is actually right down to nail pattern. We know how many nails, other than the waste, of course, actually goes in each house, how many staples goes in each house. This is the floor line. There is The schematic here, you see there are two tables. Each one, handles floors up to 40 feet. That's a bridge, the automated bridge, that travels from side to side. When they're preparing the floor on one side, the other side is already prepared, so the bridge will work on that side. In theory, of course, we're still working on it. And then the machine will go on that side, start to glue or nail or cut, whatever they do, and then they prepare the floor for this on this side so that the bridge will go back and forth for efficiency. These are different components of the machine. The saw here is probably the most important part of the floor, of course, because it cuts. It has to be a high-speed saw, and it has to cut all the joists to supply enough joists for 3 to 3. We build about 3.2 homes a day out of this plant every day. So here's a sample of a floor, for example, that you see. This floor has to be split into sections that are less than 12 feet wide because of our transportation laws, of course. We cannot transport anything wider than 12 feet unless we have to get license and pilot trucks, and becomes kind of onerous. So also, of course, the bridge, the machines, the robots, it's difficult to make them too wide. The widest one is about 14, 15 feet wide, but ours handles up to 12 feet of wall. So then that's a sample of one section here. That this floor is engineered ahead of time before it goes into 3D modeling, and then of course it goes on the to the bridge, and after components are cut. So that is again that one was the layout, the drawing from engineering drawing, but this is now the model that created by the software. We use, by the way, a software called SEMA. It's a German software. It was produced originally for manufacturing, and they have been continuously improving it. So you notice that we're talking about, I would call two types of BIM. One is the macro BIM, one is micro BIM, and this is, we're talking about the micro, the very small scale. So we go to right down to nail patterns, for example, and the number of nails. So here you can see that all the detailed information is on that sheet. You can on this drawing here. I should have put that another drawing here, but you can grab this drawing, you can rotate it upside down, inside out. You can zoom on any corner. We see, for example, how it's nailed, connected together. The next one would be the sheeting pattern. Again, all information about sheeting and also the nail pattern of the floor. So you break down the BIM in our factory in several sections. Number one is that before we could have a 3D model, of course, we have to have an architectural drawing, which I keep pressing the wrong button. Here is the architectural drawing. Of course, we have to have that. From there, we have to create structural design for the floors. Ultimately, when we do the roof panels, also we have to do the same thing. Then we have to feed the software with the knowledge base information so the software knows what to do. For example, how do you connect the two exterior walls, 2x6 walls at the corner? Or how do you attach a 2x4 interior wall to a 2x6 exterior wall, for example? Or the codes, for example, that we cannot have any two studs separated more than 24 inches, for example. So when you feed information together, then the software can actually decide how to design the wall and build the wall, or floor for that matter. So after that, the next process, of course, is that we create from the 3D model that's in the center here. No, I keep doing that. Sorry. Yeah, so we created the 3D model, and from here then we get, of course, the cut list, okay, which will be fed into the machines. By the way, what we do is that we feed the machines with 3 homes at a time. And the advantage of that, of course, is that when materials are cut, for example, on the panel saw we use for the sheeting, if there is an odd size, let's say piece of OSB left, let's say 36 or 34 inches or whatever, the software looks through all 3 houses and finds the closest match to it so that there is the least amount of waste created. So we literally, when you look at the panel saw, for example, with OSB, there is a bin, a reasonably small size bin, and for the whole day, you know, sometimes we empty it only once, or sometimes we don't empty until the next day. Very little waste generated. Of course, that information then is translated into a data file or a WUP file, and the WUP files are known for, they call them WUP files, the files that drive the CNC machines. So the information created then is entered in all the machines, the saws. We have two saws. We have a, that's component saw. They cut 2x4, 2x6 joist or any kind of lumber, dimension lumber. And we have a panel saw that cuts OSB sheets. These are pre-cut already for the walls and for the floors. So the data is fed into all of them. Now, each machine, when they cut, for example, let's say for house 1 and the next cut is from house 3, then they print a sticker, a label that it says actually gives the information for that particular element, whether it's wall or floor, and it says which house it is. So we have 3 carts that they pick these cut elements and put them in the right sequence. So that when they manufacture and it goes, they take that particular cart to the right machine. Then again, from the BIM, the 3D model, we can then produce a installation drawing that when they go to site, they can assemble the house. The same thing with here with the floor, of course. So one thing that we did right at the very beginning, we recognized that when you do stick frame houses, site construction, you have to build the walls and the essentially the outside walls first and the inside walls, and there's always a hole left in the middle, and that's where the stairs are assembled. So that obviously introduced a element of danger. It's not very safe. We have had over the period of 30-odd years or 35 years, we have had several falls. Our people have. So we decided to actually build we just refer to it as a stair cage. So as you can see, it's essentially the stair with the wall surrounding it. And that goes to site as one piece. So before we actually start the main floor, we install the stairs, and then the walls go around them. So right from the beginning, there's no ladder used in there, so you can walk up and down the stairs, and that is very, very important from the safety aspect. So the next part of the BIM, of course, is the mechanical and electrical. And that's something that we started recently because it's a progression in our case. There's so many things involved that. So now we have started actually designing our heating and plumbing. And we have about half of our plans now designed, and we invite then the plumbers and the heating contractors to come and give their opinion. There's a tremendous amount of waste in actually heating and plumbing. You know, And you can imagine that the contractor goes to site and they have to go to 3 floors, basement, main, and second floor, and have to constantly come down, up and down, drive a nail to see where it comes out so they can locate their pipes. And of course, here at we have the drawings and 3D drawings, and we can determine, separate the heating and plumbing altogether so that they don't share the same joist space. And also we keep working at it until we come up with the shortest distances, shortest length of pipe, the least number of the joints in a Y or T sections, for example, and that's a lot of saving. And then we produce, of course, a 3D drawing that it would visually help the contractors on site to see where they don't have to look. And all the holes are, of course, pre-cut, so the contractor can go and just install it very quickly. Now, in the future, of course, we can actually install some of these or most of these in the plant, in the floor space or in the wall space in cases like that, and then connect them together on site. But we are not there yet. At the moment, what we were doing prior to this one here, we just cut some holes which are because the knockdown holes that if they needed a pipe here, they would knock this part in. But that's very inefficient. That's why we now switch to the design. When we design, we have no problem. Then we will have a hole exactly where it's required, exact size that's required. So roof is this methodology, of course, is used in Germany and Austria. This type of construction. And the odd places in Finland for sure, and a few other smaller countries in Holland. However, their houses are, their roofs are much simpler than ours, so they use paneling for the roofs, which is very, very efficient. We have very complex roof structure, and we use trusses. It's very bulky, so it has been a problem for us. So up to now, we have been actually building the roofs on site, and prior to installing assembling the whole house. But now we started to, and that sometimes is onerous because the roofs are very large. We need very large cranes. It's inefficient and it's costly, and more important than anything else. For example, it's very dangerous when you get into areas with narrow streets, or when you're building a house, as we call it, infill, in between two homes already constructed. To lift a huge roof is dangerous. So that's why we started this process of manufacturing these in sections in the factory. Now, but under 1/2 of the houses are now built this way. The advantage, of course, also is that we can finish put the trim, decorative trims on these, the gable ends, which is dangerous for site work, because usually the siding people work on ladder, and there's been a lot of falls because of that at that point. They're very, very efficient, very time consuming. So this has been very, very successful, and we're going to switch to, excuse me, all our floors to this one. We just are creating some space now, so to do that. So the part 4 of BIM, of course, is again to add value, and that is plumbing, heating, electrical, drywall, exterior cladding. So the reason that the drywall we said in the 3rd quarter of 2013 is that drywall itself is really not a very difficult thing to install in the plant. In fact, it's very easy. It's just like installing sheeting. But we have never had a situation in North America where the wires were not exposed for inspection. So electrical inspections like to see the wires and to pass it before it's covered. So now, of course, we have this dilemma. City of Edmonton has been tremendous and been championing our cause, and really helping us. But you know, the bylaws and our rules are rules. So we have to find a method that we could close the walls and satisfy the electrical inspection, or until such time as the codes will allow us to recognize the this government manufacturing that's panelizing, and they allow us to do that. So we have been working with conduits to install conduits, and we also are looking at designing wireless switches. They exist today, but the cheapest would be about $65 today per switch and light box. So we are actually doing research on that ourselves to manufacture that. So and that's why the exterior cladding is very easy, stucco or siding. We can do it. Actually, we have started already testing. So, and electrical is, of course, in continuous battle, and we're working on it. So that's pretty well it. So BIM is we can afford them to manufacture. Without it, it would be impossible. Of course, the benefits are quality, productivity, waste reduction, and resource planning and cost control. The cost control is the biggest thing. Once we achieve siding and drywall, the cost will come down substantially lower than stick framing. Thank you very much.